In this video series, we'll be exploring an introduction to relationships, specifically recording data from a two-variable experiment, putting it into a table of values, and then graphing a scatter plot. In the candle burning 3-act math task, we watch a candle being lit and eventually burning down to nothing. While students typically bring up many different questions that they have after watching this video, typically the most popular is how long will it take for the candle to burn out? Or in other words, at what time will the height be zero? When working with two variable relationships, we need to identify the independent and dependent variables. Information commonly requested by students is how tall is the candle before it starts to burn. The longer we burn the candle, the lower or shorter the height of the candle will be. We can state that the time must be the independent variable and the height must be dependent, since the height does depend on how long we burn the candle for. It should also be noted that we can show this information as a point or a coordinate 0, 17, since 0 is the value of our independent variable and 17 is the value of our dependent variable. We'll repeat this process for the remainder of our data points, such as after 24 minutes, the height of the candle was reduced to 15 centimeters, and so on. This table of values will help us organize our data as we prepare to graph our scatter plot. Since independent variables cause the dependent variable to change, we typically put the independent variable along the horizontal axes, while the dependent variable, the variable changing when the independent is increased, we put that on the vertical axes. The horizontal axis is also known as the x-axis, while the vertical axis is also known as the y-axis. Selecting an appropriate scale for the x-axis and the y-axis is very important to ensure we have an accurate scatter plot. We're now ready to plot our points on the graph. So beginning at 0 on the x-axis and going up from the origin to 17 on the y-axis, we can then plot the point 0, 17. The point 24, 15 can be plotted in the same manner by moving from the origin to the right along the x-axis to 24 and up vertically to 15 on the y-axis for height, and then plotting the point 24, 15. Starting again from the origin and moving horizontally to the right to 50 on the x-axis and up to 14 on the y-axis, we can plot the point 50, 14, and then repeat the process for our 3 remaining data points. If it appears that a trend exists, you should draw a line of best fit or a curve of best fit to help you make predictions. Going back to our initial question, how long will it take for the candle to burn out, we're going to have to use the line of best fit to make this prediction. And we can see that it appears it will take approximately 360 minutes for the candle to reach a height of 0. Again, it's important to note that the 360, or the first value, represents the x value, and the second value, 0, represents the y value. So in this case, x being our time in minutes and y being our height in centimeters, this point can be put into a sentence. After 360 minutes, the height of the candle decreases to 0 centimeters, or in other words, the candle completely burns out. But keep in mind, this is only a prediction according to our scatter plot. Let's take a look at what really happened. Although not exact, our prediction was fairly close to the actual time of 362 minutes for the candle to burn out.